Often the most important choices we make are not about giving up something now so we can have something else now, but rather about giving up something now so we can have something in the future, or giving up something in the future so we can have something now. We can illustrate such trade-offs along what we call intertemporal budget constraints, or budget constraints that illustrate trade-offs across time. Consider, for instance, the case where you've lined up a job this summer that'll pay you $10,000, but you don't intend to make any money next summer when you plan to vacation instead. Your choice now is whether to consume now, or consume in the future, or do something in between. It is an intertemporal choice, a choice across time. In this setting, your endowment bundle, E, is consuming $10,000 now and nothing in the future. It's your endowment bundle because it's what you own. You're going to make $10,000 now and nothing next summer. And no matter what the interest rates are, you can always consume that bundle. Suppose you could invest your money at a bank that'll pay you 10% interest over the coming year. If you took all of your $10,000 and put that into an investment in this bank, you would have $11,000 next year, your original $10,000 plus $1,000 in interest. Therefore, another bundle that you could choose is to consume $11,000 next year and nothing this year. This is bundle B in our graph. Of course, your behavior doesn't have to be so extreme as to cause you to consume either at bundle E or at bundle B. You could choose anything in between on the budget line that connects B and E. This is your intertemporal budget constraint if the interest rate that you face is 10%. The slope of this budget constraint is minus 11,000 divided by 10,000, or minus 1.1. This implies that whenever you consume $1 now, you're giving up $1.1 worth of consumption next summer, which makes sense given that the interest rate is 10%. The 10% interest rate is therefore incorporated into the slope of the blue budget constraint. That slope is minus 1.1, or minus 1 plus the interest rate, expressed as a decimal, 0.1. This will generally be the case for intertemporal budget constraints. The slope will be minus 1 plus the interest rate expressed in decimal form. If the best interest rate your bank offered you were 5% instead of 10%, however, your intertemporal budget constraint would rotate inward. This is because if you saved your $10,000 at 5% interest, the most you could consume next summer would be $10,500 instead of $11,000, the original $10,000 plus $500 in interest. Thus, the vertical intercept of your intertemporal budget constraint would shift down by $500. Your horizontal intercept, on the other hand, bundle E, doesn't change. You can still consume $10,000 now because the $10,000 that you earn now don't depend on the interest rate. Our 5% interest intertemporal budget constraint therefore has a vertical intercept of B prime and a slope of minus 10,500 divided by 10,000, which is equal to minus 1.05. Notice that this is again equal to minus 1 plus the interest rate, with the interest rate being expressed as a decimal, 0.05.